In this video, we're going to cover section 1.6, which is on the product and quotient rules. This is going to give you formulas on how to find derivatives of the product of two functions when they're multiplied together, and the quotient, meaning when they're divided. So our objectives are to learn how to differentiate using both product and quotient rules, and then utilizing quotient rule to find to differentiate the average cost, revenue, and profit functions for a few applications. All right, so here is the product rule, theorem 7. Let capital F of x equal f of x times g of x. Then the derivative, capital F prime of x, is the derivative of the f times g, which is found by this formula. So we're going to take the first function f of x, multiply it by the derivative of the second function g, then add what I get if I took just the function g and multiplied it by the derivative of f. So your formula for differentiating a product is to leave the first one alone and multiply by the derivative of the second, plus this time leave the second one alone and multiply it by the derivative of the first. So it's not just take the derivative of each and multiply. You have to use this formula when you have a product. All right, our first example, find the derivative with respect to x of the product of this function, x to the fourth minus 2x cubed minus 7 times the function 2x squared minus 5x. So our rule for finding the derivative of the product would be the first function, x to the fourth minus 2x cubed minus 7 times the derivative of the second, so this is where they're getting this 6x minus 5 comes from differentiating this. So bring down the 2 in front. That gives me a 6x to the first, because this gets reduced by 1, minus, then the derivative of the 5x is just 5. Remember, the derivative of any linear function, meaning a power of x being 1, is just the coefficient. Plus, this time we take, this is my g of x, so this function, 3x squared minus 5x, gets multiplied by, this function is the derivative of the first. The 4 coming down, leaving x to the third, so 4x cubed minus the 2 coming down, giving you 6x to the second, and the derivative of the 7 is 0. So this is my first function times the derivative of the second plus the second function times the derivative of the first. So that's just applying the formula. Okay. We should simplify this. They did not simplify this example, but most of the time we would distribute and combine like terms. Okay, so we'll see that done a little bit later on. So let's look at another example. Use the product rule to differentiate. It says not to simplify, so just pay attention to your directions. If it says not to simplify, you would just do like the last problem and not, but otherwise you would. All right. So 2x to the fifth plus x minus 1 times 3x minus 2. This is a product, so we have to utilize the product rule. All right, so this is what the product rule says. First times the derivative of the second plus the second times the derivative of the first. All right, so the first function is this. This is the derivative of the second. This is going to be 3 minus 0. Plus, this is the second function. This is the derivative of the first. The 2, they're just showing all the steps here, right? The 2 staying, the 5 coming down, right? And then going term by term. I probably would have skipped this step right here and just gone straight to this one. So the first function, which is this, the derivative of the second function is just 3, because that's a 3 and that's a 0, plus the second function, which was this, times the derivative of the first, which is 10x to the fourth plus 1. Right, because that derivative is 0. So that's your answer. Then don't simplify part means don't distribute and FOIL and combine like terms. Just stop there. All right, our second example, we have a product square root of x plus 1 times the fifth root of x minus x. So again, our product rule. The first function, square root of x plus 1, times the derivative of the second. So it looks like here the derivative, they skipped a step here. This should have been written this as x to the 1/5, right? So that 1/5 would have come down to the front. And then they would have gotten 1/5 minus 1 minus And then here we've got the coefficient is already 1. Drop down the 1 and then 1 minus 1. Plus second function times the derivative of the first. Again, that x to the 1/2 would have put the 1/2 in the front times x to this power, right? 1/2 minus 1 plus 0. Let's see if they fixed it on the next line. Yeah, they fixed it here. So there's a typo up here. So first function, this derivative would have been 1/5, right? 1/5 x, this new power is negative 4/5, so they put the 4/5 on the bottom and then rewrote it as a radical, minus x to the power of 0 is just 1. And then this function stays as it was. This should have had the 1/2 in front by bringing down the 1/2 power first. So there's the 1/2 in the front. X to the new power, this new power is negative 1/2, so that x to the positive 1/2 on the bottom, back to turning it back into a square root. And so then that would be it. So they are wanting you to simplify a little bit here, right, from this step, but not to go any further than that. All right, quotient rule. Derivative, if the function is defined as q of x equals capital N over x divided by capital D over x, then define the derivative of the quotient. We take the denominator function as it is times the derivative of the top minus, then take the numerator as it is times the derivative of the bottom, and then we divide the whole thing by the denominator squared. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, so let's try an example. F of x equals x squared minus 3x over x minus 1. Okay, so the quotient rule says f prime is the denominator, x minus 1, times the derivative of the numerator, which would be 2x minus 3, minus the numerator, x squared minus 3x, times the derivative of the denominator, which would just be the 1, divided all that whole thing being divided by the denominator squared. So here we're going to clean up the top. So we're going to FOIL. X times 2x is 2x squared. The outer is negative 3x. The inner is negative 2x. So that's negative 5x in the middle plus 3 on the end. Then we're distributing the negative 1. So negative x squared plus 3x. Just clean up the top. They left the bottom as x minus 1 squared. Don't worry about foiling that out. And then further cleaning this up is 2x squared minus x squared is just x squared. The negative 5x and the plus 3x is minus 2x. And then the plus 3. So just collect like terms and that's it. All right, here they want us to try another one, differentiate, and they do ask us to simplify here. All right, so derivative using quotient rule. Derivative of f of x over g of x is the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. All right, so our function, the denominator, times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. Cleaning this up, you can drop the 0 here and just distribute negative 3, so you get negative 3x squared minus 6. Here you're distributing, this is just 2x, so you're distributing negative 2x. So that's negative 2x plus 6x squared. And then here they went ahead and foiled the denominator. I would recommend not doing that unless it's required in my math lab. It's not wrong to foil it, but for things we're going to need it for later, I usually don't, but I guess that's kind of just up to you. And then they further cleaned up like terms on the top. So negative 3x squared plus 6x squared is positive 3x squared minus the 2x minus 6 over the x to the 4th plus 4x squared plus 4. And you could have left the bottom as x squared plus 2 quantity squared. That would have been fine. All right, application. If capital C of x is the cost of producing x items, then the average cost of producing x items is the cost function divided by x. So average cost, divide the cost function by x. If capital R is the revenue from sale of X items and the average revenue of selling X items is capital R of X over X, so average revenue is the revenue function divided by X. And then likewise, if the profit is capital P, then average profit from selling X items is capital P divided by X. So finding average cost, average revenue, or average profit means take the function itself and divide it by X. All right, so our example. Paulison's greenhouse finds that the cost in dollars of growing X hundred geraniums is given by C of X equals 200 plus 100 times the fourth root of X. If the revenue from the sale of X hundred geraniums is given by R of X equals 120 plus 90 square root of X, find each of the following. The average cost, the average revenue, and the average profit when X hundred geraniums are sold. So just knowing that taking the cost function dividing by X, revenue divided by X, and finding profit dividing by X. Then find the rate at which the average profit is changing when 300 geraniums are being grown. All right, so part A. We're going to let A sub C, A sub R, and A sub P represent the average cost, average revenue, and average profit. So average cost, we said, was cost function divided by X. They gave us our cost function divided by X. So that's our average cost. Revenue, same thing. We take our revenue function that we were given divided by X. So that's our average revenue function. And then remember from before, we talked about profit being revenue minus cost. When we talked about, I think it was back in chapter R. So you've got average profit being the profit function divided by X, but profit is what you take in from revenue minus your costs. That's how much profit you make divided by X. So we take our revenue function. Since we're subtracting costs, notice the negative is distributing through each term of our C function. So they're both minus here over X. And then there is a simplification here. The 120 minus the 200 is the negative 80, plus the 90 squared root of X minus the 100 fourth root of X. So they just kind of cleaned up a couple of the like terms for average profit. So that was part A, finding those functions. All right. Part B was finding the rate at which average profit is changing. So when it said find the rate at which it's changing, that's telling you to find a derivative. So the rate at which average profit changes is the derivative of your average profit function. And then it wanted you to calculate it when 300 geraniums are being sold. So remember that it defined our functions for X hundred, right? So if they want it for 300, we're going to plug in a 3 when we're finished. All right, so our derivative of our average profit, remember that was a quotient. It was our profit function divided by X. So we would take the denominator, which was X, times the derivative of the numerator. That would be the derivative of our numerator from our average profit function, minus the numerator times the derivative of the denominator, divided by the denominator squared. So we're just utilizing the quotient formula, the quotient rule for finding a derivative of that profit function. There's some square roots and fourth roots, so you got to be careful there. So just watch your signs and your fractions. All right, then this has been cleaned up, distributing the X. So 90 times a half is 45. Distributing the X here, you're adding power. So 1 plus negative a half is a half. Again, distributing it here, 100 divided by 4, that's where the 25 comes from. And then 1 plus negative 3/4 is 1/4 power. Here we're distributing the negative sign, right? Otherwise just the 1. So plus 80 minus 90x to the 1/2 plus 100x to the 1/4 over the denominator squared. So there's our rate of change of average profit, how fast it's changing. So now we've got that simplified. We're going to evaluate it at 3. So plug in a 3 for all the x's, and then use your calculator to simplify that. So 11.196, meaning that when they sell 300 geraniums, the average profit is changing, right? Meaning since it's positive, we would say it's increasing by about $11.20 per plant. So the rate at which something is changing means find the derivative of that function. All right, so our summary here for this section, 2 formulas. It'll take some practice. This is a fairly short section, but it's just, you got to practice the formulas, so that you should spend some time on this. Derivative with respect to x of the product of 2 functions. Product rule, first function times the derivative of the second plus the second times the derivative of the first. And then your quotient rule, the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. This note down here is important. Be careful to note the order in which you write out the factors with the quotient rule. Okay, make sure you're differentiating the numerator in this first term. So it's the bottom left alone times the derivative of the top minus, then you leave the top alone and multiply by the derivative of the bottom. It matters because you're subtracting. If you get them reversed up here, it won't matter if you did this first and then added this, because addition is commutative, but it will matter on the quotient rule. Quotient rule involves subtraction and division, so the order in which you perform those operations will be important. All right, so that is the end of section 1.6.